So question 2f. The amount of power in kilowatts used by a heater T's after it's switched on can be modeled by this. The amount of energy used in the heater can be estimated by the area. Okay, so this under here is the energy used. Okay, so given that PT is continuous, that is the perfect join at 0.4 and 1.5, show that A equals that. Okay, so that I know that 0.3 plus A e to the minus 10t has to equal 1.5 given t equals 0.4. And then I've got to show that A is equal to that value. Okay. So I move that over and I get A times e to the minus t times 0.4 equals 1.5, 1.2, and that A equals 1.2 over e to the 4t, which is to the negative 4, which is 1.2 e to the 4. That's correct. How long does it take for the heater switched on until the heater used 0.5 kilowatts of energy? Okay, so before I start, I'd like to find out what energy used in this rectangle here to know whether I need to integrate this bit or this bit. So 1.5 by 0.4 equals 0.6. So there's 0.6 used here, therefore 0.5 is going to be somewhere in here. So 0.5 equals 1.5 times the time. So if I make that an x and make it equal 0.5, solve for x, x equals 1/3, and that's 0.33333. So for 1 mark, I'm happy to say that t equals 1/3. To the next question, which is now worth 2 marks, how long does it take for these switched on? 1 kilogram of energy. Okay, so I want 1 to equal, I know that it's 0.6 plus, so 0.6 for the first bit. So then I'm going to be integrating the integral from 0.4 to t, no, let's call that p, of, now my rule is, what's my rule? My rule is 0.3 plus 1.2 e to the 4 e to the minus 10t dt, and solve that. So I'm wanting 1 equals 0.6 plus the integral from 0.4 to, I'm going to call it y, of 0.3 plus 1.2 e to the 4 e to the minus 10x dx. And if I get that answer and I solve it for x, no solution. Solve for y, many solutions exist. So I'm looking at p equals 1.3333688692 to 2 decimal places. The time equals 1.33 is going to be my answer.